For most of astronomical history, our solar system was considered a finished puzzle. We had counted all the planets, mapped their motions, and pushed the remaining mysteries out toward the distant stars. But over the past decade, something unsettling has quietly emerged, an inconvenient pattern, a whispered clue that something massive might still be missing. Far out beyond Neptune, where sunlight is a faint glimmer and everything moves in slow motion, astronomers began to notice strange behaviors. The small, icy worlds out there weren't moving at random. Their orbits were clustering, tilting in the same direction, and bunching up, as if nudged by a common source. Not a collision, not chance, but gravity. At first, the idea seemed too radical. Another planet meant we'd misunderstood our own cosmic backyard. But the math kept pointing the same way. When researchers tried to simulate the outer solar system without an unseen object, their models failed. Add a single, distant, massive planet, and suddenly the chaos made sense. This wouldn't be a close neighbor or something obvious in our night sky. If it exists, it lives in profound darkness, taking thousands of years to complete a single orbit of the sun. Slow, cold, hidden, yet powerful enough to shape the paths of worlds billions of kilometers away. What's unnerving isn't just that we haven't seen it, but that its fingerprint seems to be everywhere. The outer solar system was supposed to be chaos. Past Neptune, gravity weakens, objects crawl, and orbits should point every which way. That randomness is exactly what astronomers expected to see, but that's not what they found. As researchers cataloged the most distant objects ever discovered, something felt off. A handful of these icy worlds had orbits aligned in space, not just vaguely similar, but pointing the same way. Their closest approaches to the sun clustered on one side, their orbital planes tilted together. With 2 or 3 objects, you might shrug it off, but the pattern held as more were found. The odds of this happening by chance became uncomfortably low. Astronomers tried the obvious explanations first. Maybe Neptune was the culprit. Maybe passing stars nudged the objects long ago. Maybe it was a bias in how telescopes scan the sky. Each idea helped a little, but none made the strange pattern go away. The real problem was stability. Over billions of years, these orbits should have dispersed. Gravity, over time, tends to break up neat arrangements, yet this clustering appeared long-lived, as if something was actively maintaining it. When scientists ran computer simulations, the result was clear. Without an extra gravitational source, the system refused to behave. Orbits scattered, the pattern collapsed. But add just one massive object far beyond Neptune, and everything suddenly clicked. It didn't need to be close or interact often. Its steady tug over millions of years was enough. That was the moment this idea stopped being a curiosity and started demanding an answer. If this unseen object is real, it wouldn't be small. Based on how it shapes distant orbits, scientists estimate it could be 5 to 10 times the mass of Earth. That places it in a strange category, larger than anything we know of in the outer solar system, yet smaller than Neptune. Its orbit would be highly unusual, extremely elongated. At its closest point to the sun, it would still be many times farther than Neptune. At its farthest, it could be hundreds of times more distant. A single full orbit could take 10,000 years or more. This isn't another Pluto. Pluto is tiny, part of the crowd, easily nudged by Neptune. This object would be the opposite. It would dominate its region, cleaning out the space around it. By the modern definition, it would qualify as a true planet. What makes this idea compelling is the specificity of the predictions. The planet's mass, orbit, and tilt aren't random guesses. They are constrained by the observed behavior of the distant objects. Alter these values too much, and the simulations stop working. There's also a precedent. Uranus was discovered in a similar way. Astronomers found Uranus wasn't moving as predicted, and the solution was another planet, Neptune, found with mathematics before it was seen in a telescope. The difference now is the scale of distance. This planet would be so far away that even our most powerful telescopes would see it only as a faint dot, moving almost imperceptibly against the starry background. The case isn't closed, but it's no longer vague speculation. It is a specific hypothesis. built to explain a problem that stubbornly refuses to go away. If such a large planet exists, it's reasonable to ask why we haven't seen it. The answer lies in distance, darkness, and time. At that range, sunlight is incredibly weak. Even a large planet reflects only a paltry amount of light back toward Earth. It wouldn't shine like Jupiter or Saturn. It would look like a faint speck of dust, moving slowly, difficult to distinguish from the background stars. Motion is another problem. Objects that distant take years to show noticeable movement. Most surveys rely on detecting motion over days or weeks. A planet with an orbit spanning millennia barely shifts at all on a human timescale. It could be hiding in plain sight. Then there's the issue of where to look. The sky is vast. The proposed orbit covers a huge swath of space, much of it far from the ecliptic plane where most planets reside. Telescopes are powerful, but they don't see everything at once. They scan in small patches, slowly, and hope something stands out. Even modern surveys struggle. They are designed to find fast-moving objects near Earth or bright distant galaxies. A faint planet drifting silently through the outer solar system is nearly the hardest possible target. Ironically, older data may already contain its image. Astronomers often revisit archival photos, searching for objects that were overlooked because they seemed unimportant at the time. A single, unnoticed speck of light recorded years apart could be enough to betray its existence. The search isn't over. It's just slow, and patience is part of the price of peering into the dark. Here is the reality. Finding a new planet in our own solar system wouldn't be a minor update. It would force us to rewrite the story of how this place formed in the first place. Right now, the outer solar system already looks strange. Giant planets orbit closer to the sun than models once predicted. Small icy worlds are scattered in ways that hint at an ancient chaos. A large distant planet could tie many of these loose threads together. It could explain why some objects were flung out instead of falling in. It could even hint at early encounters with other stars, when the sun itself was still forming.
There's also a broader implication. Astronomers frequently find planets around other stars with wild, elongated orbits. Until recently, our own system looked exceptionally tidy in comparison. An eccentric planet far out would make the solar system feel less like an outlier and more like a familiar example. It would also change how we define what's detectable. Discovering a planet primarily through its gravitational influence would be a reminder that observation isn't just about seeing light, but also about recognizing patterns that refuse to conform to ordinary rules. Perhaps most importantly, it would shift perspective. We tend to think the solar system is fully explored because probes have visited every known planet, but those missions focused inwards. This would be a reminder that the distant frontier is still vast, poorly mapped, and fully capable of hiding major players. Such a discovery wouldn't feel like closing a chapter, but like realizing one has been missing all along. The idea of another planet is unsettling because it challenges something familiar. We grew up learning solar system maps as if they were complete, fixed, and stable, but gravity doesn't care about our charts. It leaves traces, and those traces hint that there's still something out there, quietly shaping the edges of our system. If this planet exists, it has been there all along. Through the rise and fall of civilizations, as telescopes improved and spacecraft left Earth, it has kept to its long, cold orbit, unnoticed not because it's hiding, but simply because it's far enough to escape notice. Whether it's ultimately found or ruled out, the search itself has been important. It forces astronomers to question assumptions, look more closely at data once thought mundane, and accept that even our cosmic backyard is larger and stranger than it appears. The solar system may not be unfinished, but it might be less tidy than we imagined. If you enjoyed exploring this cosmic mystery with us, smash that like button and subscribe for more adventures into the unknown. Your support fuels our mission to uncover the universe's greatest wonders. Thanks for watching.